Good morning. Professor Kumar from Christianity College. Welcome back to Network Information Security course. Today we are going to see the public key cryptography algorithm, key exchange algorithm, Diffie element key exchange algorithm. Diffie element key exchange algorithm is an important algorithm which is used to exchange private keys. The important point to remember in Diffie key exchange algorithm is primitive root. The algorithm is demonstrated by a numerical example by Ms. Ankita.
I will be demonstrating of Diffie-Hellman key exchange algorithm. So what is Diffie-Hellman key exchange algorithm? It is a method for securely exchanging cryptographic keys over a public communication channel. And this algorithm is named after their inventors Whitfield Diffie and Martin Helfand. So in Diffie-Hellman key exchange algorithm, if we think user A and B is there, so if they wish to communicate with each other, they first agree between them Q and alpha. So what is Q? Q is actually a large prime number. So I will be taking 23, that is a prime number, and alpha we need to take as if it is alpha, it should be greater than Q, that is greater than that prime number whatever we took, and alpha should be primitive root of Q. So that's how we have to calculate the alpha. So it should be greater than Q and it should be the primitive root of Q. So I am getting the value that is 5. So I will be taking alpha as 5. So next, think user A and B is communicating. So here user A will choose one private key from his side, that is XA, anything that can be. So we are choosing that 3 as private key, and same as user A, user B also choose one private key, that is 7. You can choose anything as your private key. So then they will calculate their key. So key generation formula is alpha XA mod Q. So what is alpha here? Alpha is about 5. So 5 to the power XA, that is our private key from user A side, okay? So 5 to the power 3 mod Q is 23. So 23. So if I do the calculation, it will be like 125 if I'm not wrong, and mod 23 will be 10. Same way user V also calculate her key, the same formula, but the value will be different because user B chose the private key as 7. So YB is equal to alpha XB mod Q. So alpha here is again 5, XB is 7 in the case of B, user B. So that is 7 mod 23. If I do the calculation, the result will be 17. So after that, here this is the public key, okay? User A generates his public key and user B also generates his public key. So they will be exchanging the public key with each other. So YA 10, YB is equal to 17, okay? So now they will exchange each other the value. So now YA will be 10 here and YB will be 17. So user A and user B will exchange the key between them. So now user A got the public key of B, user B. So he will proceed for generating the secret key.